Hello and good evening, and welcome to part 2 in the IPv4 and IPv6 route summarization supplement. A number of students had asked for some additional material to be done up on IPv4 and IPv6 route summarization, and so that is what we're doing this evening. So this is a continuation of the IPv4 video that I had done up earlier, part 1. And so now what we're going to do is we're going to go ahead and we're going to jump into the IPv6 portion of route summarization. And I guess we're just going to go ahead and we'll just jump right in here again. So we have this drawing over here, again, a bit much for the CCNA level, but it is going to be good to demonstrate some of the things that we're trying to do. So let's pick up where we left off here. We're going to go ahead and change these into IPv6 networks that maybe are sitting behind router 7, right? And so we'll go ahead and use the 2001:DB8 ACAD I'm running out of space quickly here. And we'll say :A /64. And yep, we ran right out of space there. So I'll go ahead, and these first 3 hextets, right? The first 3 hextets are going to remain the same for all of the addresses. So then I'll just simply say this guy would be :B /64, and not 641, but 64, and this guy would be :C /64. And so if we wanted to summarize these IPv6 addresses here, how would we do that? Well, it's very similar to how we did our summarization with IPv4. And so the first thing that we did was we wrote the addresses out. So we'll start out here with 2001:DB8 ACAD and we'll start with A first, :/64. And I'm not going to write the first 3 hextets out again. Those will remain the same. So we just said :B :/64, and then :C :/64. Now the key thing to remember here is with our IPv4 addresses, when we wrote those out, and we'll put one up here real quick, 192.168.10.0/24. The /24 at the end, we refer to that as the subnet mask, right? And it shows up in the CIDR notation. However, with IPv6, this is referred to as the prefix, and shouldn't really be a dash there. Let me undo those last 2. So prefix length, right? So with IPv4, so we'll say v4, it's the subnet mask, right? And that's CIDR notation there, that's slash notation. And with IPv6, we need to make sure that we refer to it as the prefix length. All right, so the first 3 hextets, and again with IPv4 this was an octet, right? So that's the octet. IPv6, these are hextets. And the reason they refer to them as hextets is there are 4 hexadecimal characters here, and each of the hexadecimal characters can be represented with 4 bits, and so you've got 16 bits total, 16 bits total per hextet. All right, so where is our interesting hextet here? So if we take a look, we can see that it's going to be the 4th hextet with these IP addresses. This is our interesting hextet here, right? And this is typically where the subnetting takes place. All right, this is typically where we're subnetting. So what we want to do, it's very similar to when we had the IPv4 address space. So these are hexadecimal characters. So the first thing that we're going to do with IPv4, what we would do is we would take this and go from from decimal into binary. So we've got to get it to decimal first. So let's do that. So we know that A in hex is equal to 10 in binary. So these are our binary equivalents. B is 11 and C is 12. So then we're going to go from binary, we're going to go from decimal, I'm going to take that out here, get that backwards. So we're going to go from decimal into binary. Now remember, each hex character is represented by 4 binary digits, or 4 bits. So we've got 1, 2, 3, 4, and their values are 1, 2, 4, and 8 respectively. So similar to the octet, however, the octet went out to 8 bits to represent the whole octet. So this single hex character is going to be represented here by 4 binary bits, or just 4 bits. So 10 would be 8, 0, 1, 0, and that equals 10. And then we've got 11 is going to be 1, 0, 1, 1. That equals 11. And then 12 is going to be 1, 1, 0, 0. And that equals 12. Now, we do something very similar here that we did with IPv4. We add up the bits, the additional bits that match. So we've got 16 here, plus 16 here, plus 16 here. So right out of the gate, we've got 48 bits that match. Now, one of the things that sometimes trips students up is one of the rules that we use in order to compress or shorten the representation of an IPv6 address is we are able to drop the leading zeros within the hextet. So this hextet that just shows A is actually 0, 0, 0, A when it's fully written out. So these 3 leading zeros here have been dropped. However, when we go to do our summarization of these IPv6 addresses and we do our calculation, we need to make sure that we recognize that those have been dropped for the purposes of writing the address out. However, for the purposes of calculating the summary, we've got to drop these guys back in, because each one of these zeros, remember, these are hex characters, each one of these zeros represents 4 bits, right? So it's going to be 0, 0, 0. Oops, it's actually 4 zeros in there, 2, 3, 4, right? So this is 12 bits total here in just zeros, right? We add the A in, we already know that that's 1, 0, 1, 0. So now we've got 16 bits, we've got our hextet. But we need to make sure we recognize that these 12 bits, these zeros, need to be added back in. The hex character 0, and then we break it from hex into decimal, or I'm sorry, it's in the binary here. And then from binary, we would go into decimal. And again, 0 in hex is equivalent to 0 in binary, and that, 0 in hex is equivalent to 0 in decimal. And when you've got these 4 binary digits here, these bits, they're all zeros. All right, so when we look at this, we're really kind of looking at the last 4 bits inside that hextet. And if you remember from your studies, 4 bits is equivalent to a nibble, where you had 8 bits is equal to a byte. So 4 bits is just a nibble. So we're kind of subnetting here at the bit boundary, or the nibble boundary, because we're interested in this last nibble. So as we take a look here, we can see that if these 12 additional bits match, we're going to add that to the 48, and that's going to take us to 60. So we've got 60 bits that match, but do we have any more? So as soon as we look at the first column here, and actually, you remember this was just written out here to to give you the values, so I'll get rid of those guys. So the first bit location does match. However, the second bit location in this nibble does not. So that's where we would draw our line, just like we did with IPv4, and we have one additional bit to add into the 60, so we know our prefix length is going to be a /61, and this is with IPv6, right? If this was IPv4, we would be saying our subnet mask would be a /24, /25, 23, but IPv6, remember, this is the prefix length. So we know we've got a /61, so half of our job is done. Now, the next part of our job is to figure out what is the full address, or what are those leading hextets going to be, and what is the value here in our summary location. So if we take a look, we know that the first hextet is going to remain the same, 2001, colon. The next hextet, same thing, DB8, colon, and then ACAD, colon, and we're going to wrap it around here. In fact, where is that my eraser? Yeah, all right, fantastic. So let's create some space here, and we didn't need those guys anyway. All right, so we'll drop back here to the pen. So we've got 2001 colon DB8 colon ACAD colon, and we know that this bit value here is equivalent to 8. Okay, so this equals 8. Now, again, the three leading zeros, we could write 0008. However, we're going to take advantage of one of the rules of condensing the IPv6 addresses, and that's simply just to put the 8 value in there, and then it would be colon /61. And so that is actually going to be the address that we would use to summarize these three addresses here. And now we need to ask ourselves the question, just like with IPv4, I've got 1, 2, 3 bits left over. So if I were to say 2 to the 3, well, 2 to the 3 is 8. So there are, or should be, a total of 8 networks that this summary is actually representing. So if we take a look here, what am I missing? What combinations of these last 3 bits in this nibble are missing? So I'm missing 000, 001. We've got 010, but we don't have 101, and we're also missing 111. And let's see, that's 4, 5, 6, 7. The last one is always the toughest for whatever reason. So there's one more missing in here, and it's going to be 1, 2, 3, 4, 1, 2, 3. It's going to be 1. And is it 01? We've got that. We've got 111. We've got 101. We've got 100. I'm drawing a blank here on the missing bit. So it would not be 111. It won't be 101. It's not 100. So 1, 2, 3, 4. Or actually, 5, 6, 7. No, yeah, we're definitely missing 1. All right, well, it'll come to me. So that would be, these are going to be the 5 networks we're missing. And so the value of this would end up being 0. The value here would be, whoops, I'm going to stay with black. The value there would be 1. The value here would be, what do we have? 1 and 5. And then the value here is going to be 4, 2, and 1, so 7. And then what are we missing? We are missing another value, and it should be 6. Is it 110? There we go, 110. Okay, and the value there is 6. So when we take a look at the bits that we have left over, we're actually going to be matching more than just these 3 networks. And so again, the prefix length is going to be a /61, and this is the summary, and it will certainly match or include those 3 IPv6 networks right there. But in addition to that, it's also going to be matching these other networks here. And so if I were to put the 8 position in there, because that position is on, right, that bit value position is in effect here, it actually changes these a little bit. So we've got, whoops, drop that out. So we've got 8, 9, this would actually be 13, right? And then this guy here is going to be 8, 12, 13, 14, 15. And then this guy is going to be 8, 12, and 13. And that is a little messy in there. And so those are going to be the additional networks. So it's going to be : 8. It's going to include 9, 10, 11, 12, 13, 14. I'm running out of space. 1, 2, 3, 4, 5, 6, 7, and 15. Right? Because if all of these values are on, you've got 8 plus 4 plus 2 plus 1 is 12, 13, 14, 15. So it's actually, these 8 networks right here are going to be represented by this summary. And so let's go ahead and take a look and do one more IPv6 summarization. So if I were to say we've got 2 networks here. So let's say we've got 2001 : DB8 : ACAD : and we'll say E as an echo : /64, and then 2001 : DB8 : ACAD : F : /64. And we want to come up with a summary route for those 2 routes. So again, we'll write out 2001 : DB8 : ACAD : E : /64, and then we'll just simply put the F there. So again, we know that these first 48 bits, these are going to be identical, and this is the interesting hextet. So the first 3 hextets are identical, and remember there's 16 bits per hextet, and then 16 times 3 is going to be 48. So then we have our E and our F. So we're going to go from hex, and we're going to do decimal, right? So E has a decimal value of 14, and F has a decimal value of 15. So then we're going to go from decimal into binary. So 14 is 1, and then 4 is 12, 13, 14, 0. And then 15 is pretty easy, it's just all ones. Okay, so we need to make sure we remember, though, that the leading zeros in these hextets have been dropped. So in effect, we have 12 additional bits that are over here to the left, which we need to make sure we account for. So then you'll see 13, 14, 15, and it's not until we get to the very last, let me change my color here to kind of highlight this, we'll go with the purplish color. So this guy here, that's where they're different, right? So we had 4, 8, 12, 13, 14, 15 additional bits. So if we add those 15 additional bits in with the 48 that already match, we end up with 63. So our prefix length is 64. It's a /63. Let's get that out of there. There we go. So our prefix length is a /63. So now we need to take a look and say, now that we know that these bits match up, how many bits did not match up? And it turns out it's 1. So 2 to the 1 is simply 2. So our summary is only going to represent 2 networks. And as it turns out, it's going to represent the two networks that we're working with and only those two networks. So now that we've come down here and we've converted into binary, now we need to go back the other direction to come up with the summary route and what that value is going to look like. So we know that it's going to be 2001 colon db8 colon ACAD colon. Now what is this value going to be? So if we take a look here, the 8-bit value position is on, the 4 is on, and the 2 is on. So 8 plus 4 is 12, and 2 is 14. And so that looks familiar, right? So that's E colon /63. Now, a very common mistake that gets made is that students will go ahead and they'll add these bit positions up, and they won't put the E in here, they'll put 14. And that's wrong. So remember that once we go from binary, right, and we figure out what the decimal value is, we're kind of working our way back this way. So we go from binary back to decimal, we figure out that decimal value, and then we need to convert that decimal value back to its hex character. So if I grab the eraser here real quick, let's clean this up. Actually worked out really well. All right. So want to remember to make sure that once you do your calculation on the binary side of things with IPv6, we've got to convert that back to his hex character, because that's what this IPv6 address is going to look like. So our summary route would be 2001 colon db8 colon ACAD colon E as in echo colon /63, and we know that this represents two networks specifically and only those two networks right there. And so this would be a very accurate IPv6 summary route. All right, so this concludes the supplement for IPv4 and IPv6 summarization, how you calculate the summarization, how you identify the interesting octet with IPv4, and how you identify the interesting hextet with IPv6. And in this video, we took a look at how we go from the hexadecimal, the interesting hextet, and we take that and we convert that into decimal, and then we break it down into binary, keeping in mind that in most cases, if you see a single hex character in that hextet, always keep in mind that there's a very good chance, whoops, didn't want to do that, there's a very good chance that you're going to have to account for the leading zeros, because most people will drop these leading zeros just to condense and compress the written IPv6 address. So make sure you don't forget these bits when you're adding bits into the prefix length, and then you do your binary conversion. After you do your decimal conversion, you convert it into binary. You take a look at that nibble, those 4 bits which represent each of the hex characters. You then figure out where the bits are the same within that nibble, and we're subnetting at the nibble boundary here, or trying to, and we're going down into this nibble. Once you figure out where they're no longer the same, which was right here, you count the bits up, add it to the preceding 12. If, for example, you had these 3 zeros that were preceding this final hex character, and then you go ahead and you finish out your prefix length, right? It gives you the prefix length for your IPv6 address, and then you take that value that you would get and go back to decimal, and then it gives you the hex character, and then you go from decimal to hex. So in our case, we had the 8-bit position was on, the 4-bit position was on, and the 2-bit position was on. That gives us 14, and then we know that 14, we had seen before, is actually E in hex. And so this is our summary route. All right, So this concludes this video. Hopefully you know a little bit more about IPv6 summarization and how to come up with the summary routes for IPv6, and that's it. So best of luck to you, and thanks for watching.